You might notice the lack of a network engineer anywhere on this slide, except for the note that says I'm not one. The last time I touched a network device CLI might have been 10 years ago, and that was during a lab at school. However, fortunately, the company I work for, PowerDNS, we do a lot of business with mostly access providers, and sometimes it's not a DNS problem when we're debugging things. So we know also some things about the networks. And at PowerDNS, I do like a bunch of things. One of them is the configuration management. So in the system administration world, there is a very, very big movement towards configuration management, automation, etc. And for me, this sentence is at the core of this. No one is or should be touching a system shell ever. Like if somebody logs in via SSH, runs a few commands, you have to shred the whole machine and reset it up because it's in an unknown state. This has been going on for years. There's a lot of different systems. In 1993 at CF Engine, which still exists and is in use, and new paradigms have been created. New software has been created as well. So I will mostly be discussing configuration management systems, at least the part of it. I won't be discussing orchestrators or Kubernetes or containers or what have you. It's going to be a very old school kind of thing. So also no infrastructure as a service, etc., etc. So many of these configuration management systems have certain properties. Not all of them have the same properties, but many of them are declarative, which means that the configuration that you put in for your systems is not a series of separate steps or commands to follow to get to a certain state, but it's usually you declare that the state of a certain package has to be installed instead of you typing, please run apt-get install my package. There's idempotency, which means that once you have declared the state, if you push the same state to the system, and the system is already in that state, no change happens, no commands get run to maybe get into that state again. Some of them are convergent, which means that you can declare the state, send the state to the device, and then the device will get into that state in a few steps. Might not be immediately. And one of the most important things is the modularity or code reusability, where you can share certain modules for installing certain things. So if you, we have Ansible modules for PowerDNS that we distribute, and it's easy for anybody to just download these modules, use them, and also contribute back, because they're on GitHub as well. From what I gathered from the documentation of these systems, when you want to apply these kinds of techniques to network devices, many of them seem to be very fancy CLI wrappers. They're also not truly declarative. Things I've seen, okay, for instance, Ansible has a Cisco module. Yeah, it works, but you do have to tell Ansible what type of Cisco you have. And if you want to bring it to a certain state, you have to put the CLI commands in the right order to get there. Some things have been then declarative within Ansible. I think you can do some very basic port things like, okay, I know this port and it has to have these properties, then that works. But if you want to do something a little bit more out there, good luck, you know how the CLI works. And many of the paradigms don't actually match. There is no system or Unix system that has a candidate data store or allows you to do proper configuration transactions where you could say, okay, please apply this configuration now. No, it's not good, roll back. There is no true way of doing that properly. So why would you actually want to use Yang and NetConf? So who here knows about Yang and NetConf? All right, excellent. So this is layman's is maybe bad. I have done some experiments with these configuration management systems, and then later Yang and NetConf for a project. So I'm looking at it from a systems engineering and mostly non-network person glasses. So from what I can see is that many, actually all vendors have separate or different CLIs on their devices, which is fine. Many of them also provide configuration APIs. And these configuration APIs, of course, differ between vendors, but at least they have an API. Then there is the SNMP, the Simple Network Management Protocol, which is neither simple nor a true management protocol. And it has a fair share of drawbacks, as you may know. One of them is it's very stateless. It uses UDP as well as for its communication. And when you want to do configuration with it, you have to put all the information in the message that you send. There is no way to tell the device, please just change this little thing. Also, the MIBs that are being used are very, very non-standardized. Each device and each vendor has their own MIBs, and there's very little commonality between them. And then there's the lack of read-write objects in many MIBs. It's a lot read-only, so it's mostly a way to read information from the device and not actually configure the device. And we're not going to talk about security of older SNMP versions here. So a couple of years ago, I think this is from 2002, in RFC 3535. I can highly recommend people reading this RFC. It is called Overview of the 2002 Internet Architecture Board Network Management Workshop. In section 3, they have the operator requirements, where the IEB describes what needs to happen or what properties a proper network management solution should have. And it all boils down to automation should be easy, and things that are common between vendors and devices should also have the same schema and be common. And this is where Yang and NetConf come from. And so these authors are, of course, a little bit biased because their book is called Network Programming with Yang. However, this chapter heading, CLI is no longer the norm. If a feature cannot be automated, it doesn't exist, rings, I hope, true for many of you. It at least does in the system administration world, and I would gather it also in the networking world, because you might have even more devices. So the IETF created the solution known as NetConf, which is a configuration manipulation protocol, and Yang, which is the modeling language for the data in there. They wrote a ton of RFCs. These are just a few of the first. They're still writing RFCs, although the Yang language itself has been at version 1.1 for, well, almost 5 years now. Well, yeah, 5 years now. So that actually means it is either nobody's using it, or it's good enough and everybody is happy with it. And fortunately, it is, at least from what I read online, it's the latter. So how does NetConf work in short? It is, of course, a nice layered protocol. You have a secure transport layer, which is defined in the RFCs as that it must have a crypto component. So it goes over SSH or TLS. On top of that, you have the different messages that can pass between a server and a client. Then you have the operations, which are partly modeled. And then you have the content, that is the configuration data, the state data, or any other data, that is fully modeled with the Yang language, that I'll get into later as well. There is, apart from NetConf, a different protocol. It's called RESTconf. Some of you might also know it. This maps this whole architecture on top of URI paths and a RESTful interface using HTTP semantics. So if you look at the full picture, on top you have Yang as a modeling language. Then you have the data models created in Yang. Because Yang is just a modeling language, you can encode or serialize the data in a bunch of formats. XML being the first one defined. There's also JSON for those who get bumps when they read the word XML. And of course protobuf and actually any structured data representation you can use. And as JSON is also YAML is also a superset of JSON. You can also do this in YAML if you really love YAML that much. Then there's the protocol that actually carries this data from the server to the client. And then there's a bunch of applications like orchestrators, development kits, Open Daylight, which is also a NetConf server, etc., etc. And those can be written in any language, just as long as you can read and write the NetConf protocol. So, bunch of protocol features. You have CRUD operations for your configuration. Because of the modeling, everything is fully declarative, so there is no reason anymore to do actually some imperative command line programming. There's a difference between configuration and operational state. So you know based on the model or the things that you're doing that, okay, I can change this, or hey, this is just state, like the port is actually up or there's something connected. It provides network-wide transactions, which have a bunch of asset properties. So you could start a transaction to create a VPN through your whole network using multiple hops. And if one of the devices has an error during the application of the configuration, it will all be rolled back because there's a two-phase commit that you can apply over the whole network. Of course, there's rollback support. And the nice thing is NetConf is just one protocol that you can implement in all controllers, devices, orchestrators, etc., without the need to have any deviation or different kinds of protocols for the configuration of multiple devices. And because of many of the models have been standardized, the inner workings of the device are somewhat invisible, meaning that you can pretty quickly switch between vendors or other different devices that have very similar properties. So what actually speaks NetConf nowadays? Network devices, I listed a few vendors that I quickly on their website could find that they supported. Cisco seems to be all in. They have on their dev days a bunch of presentations as well on NetConf, and they seem pretty happy with it. Like I said, I'm not a networking guy, so I assume they are. A bunch of orchestration frameworks, some network management systems, and there's even configuration management software like Ansible and Puppet that have NetConf modules. Some of them without actually the modeling, so you will have to do raw NetConf messages, but it exists. Also, Yang and NetConf are part of the ETSI, NFV, and American MANO standards for network function virtualization. So Yang, for those who don't know, stands for yet another next generation, which tells you something about how often we've tried. So the language, it is quite human readable. It has many built-in types. It has different integers, all kinds of. It has booleans, like anything you could reasonably expect from a programming language or a data definition language. It has it. The types are reusable. So here on the right side, you see that I create something that's called an endpoint. I give it a description, And then I have what's called a leaf, because everything in Yang is a hierarchical tree structure. And it's called IP address, and it uses the type INET IP address no zone. And that is something that the IETF defined. So it is a IPv6 or IPv4 address without any zone information attached to it. And it is mandatory to set in this type called endpoint. And there's a port, which is a port number, and that is defined as a uint, what's it, I think 16, yeah, 16. Then you can do derived types. So I could even create a type that says, well, I'm actually IP address no zone, but I'm going to restrict it to the first octet being 100. That's even possible. You can do data constraints, like the mandatory, if I have a value here, it must match a value in a different part of the tree in this model. It's modular, so you can just create different modules that can be imported by other modules. And it's versioned, because when you do an import, you actually must import from a versioned Yang model. So when you have a module, for instance, like I said, it's hierarchical. I create a container called listen addresses. It has a list, which is called listen address. When I was working on creating models, I realized that you have to flip your brain a little bit, because the listen address, singular, is a list. You call listen address, but you must name it singular, because every item is called a listen address. And also, a list in Yang is actually what we would call a map or a hash map. So it has a key and a value. So here the key is name, which is a string. Then there's IP address and port, which has the constraint that within this list has to be unique. So I can not create something with a different name and the same IP address port combination. And it uses the endpoint that I defined on my previous slide, and I refine it a bit. If it's unset, it will default to 25. So this is another nice thing about the modeling that you can do. Then there's of course the state data or operational data, which here is marked as config false. So you cannot set it; you can only retrieve it. I have a thing called the connection count, and it is a uint 32. So when you look at the hierarchy of this whole module, it's very short, but this is how it looks. So there's a read-write thing called listen addresses. Then within there is a read-write thing called a listen address, and there are 0 or more of them, and they're keyed by name. Well, then you see what goes in there, and then there's a read-only thing called counters, and in there is a connection count, which is also optional. So the reuse of all these modules, there are the IETF alongside the OpenConfig project, the Etsy, the Broadband Forum, and a bunch of vendors are creating a lot of modules. For instance, for interface types, for IP addresses, for full TLS server and client configuration, including X509 certificates, SSH server and client configuration. And it's used by many vendors to model their devices. So once you have a bunch of vendors doing this, the models actually look similar enough for you to quickly understand what's going on. And they're all published on GitHub as well. So now we come to how would you use this in a systems engineering environment. So this is a straight-up copy or a screenshot from one of the RFCs. There is a NetConf engine running on the NetConf server, which would be, in our case, a Unix server. It has all the data, so it has the configuration data, the state data, notifications, operations, etc., based on the Yang modules. And underneath there's just the software components that you can control using NetConf. So does any of this actually make sense for a system management operation? And when you think about it, it could. Many applications could be what is known as a network function within the NFV space. So if you would have a DHCP server that actually runs on a Ubuntu system, it could be a network function, especially if your core business is networking and not system administration. You can just model or have a model of a DHCP server, spin up a Ubuntu VM with the right software, and configure it via your NMS. With the right orchestrator, you can have all your infra, of course, versioned. This comes very close to what most of us are doing with Ansible for our systems. And even without NetConf, Yang is actually a very powerful data modeling language that you could use for configuration or defining your configuration of your daemons. And if you're already using Yang and NetConf, it is even better because you don't have to learn anything new. And we know that especially the older people hate learning anything new. Maybe a fun observation from what I gathered, many of the telcos that I deal with have very little with configuration management. We've deployed very big DNS infrastructures where the department was like, sorry, what is this Ansible thing you're talking about? And this was 3 or 4 years ago. So it's, if they have something, they don't like to switch. So there is a bunch of software for Unix-like systems. There is libyang, sysrepo, netappear2. These all work together. So the first one is a Yang parser and toolkit. The second one implements the Yang data store. This includes the configuration database, the candidate database, etc., etc. It does all the transactions. There's netappear2 that uses the other two pieces of software to implement a NetConf server. They're written and maintained by SESnet, which is the NREN of the Czech Republic, so like the SurfNet of the Czech Republic. It's written in C, and many of these pieces of software have wrappers for other languages. So this is a bit of an architecture of sysrepo. So there's the network management system, has the models, talks NetConf. Then there's netappear that is installed on the system. It exposes an SSH port for communication. Then does some IPC to the data store. And then that IPC, that sends IPC to any of the plugins, because sysrepo is a plugin-based system where plugins can claim part of the whole tree within the Yang data store, either on a callback mechanism. So if something happens in this part of the tree, do send me please call this function, and then I will provide you with the data or the things you need, or the other way around. I claim this part of the tree, and I will update the data in the data store if needed. So does this work? So I've done a project for this. And the answer is yes-ish. So there is the ISC Kia DHCP server that is fully modeled with Yang and uses NetConf for configuration via netappear. And it's in production in a countrywide ISP that has their whole network modeled on Yang and even deploys all the modem configuration of the end users using NetConf and Yang. Many plugins exist for sysrepo. However, the C API is very C, which, yeah, it's not for me. Also, because this is written by the NREN, the software is also a bit academic, but much to their credit, if you make a bug report, ask a question, they are very fast with answering, helping you, etc. But it is a piece of software that requires a lot of head desking at places. Also, there's the versions of sysrepo that are released, which is 0.7, 1.0, and recently 2.0, are incompatible with each other. So if you have a device, or if you want to install sysrepo but don't have a plugin for 2.0, but only 1.0, it probably won't work. So you cannot do all the plugins on the same machine. No OS has packaged any of these pieces of software, probably because of the state and flux they're in. And in older versions, badly written plugins could crash the whole sysrepo process, meaning that you have no configuration management at all. So, in conclusion, I From what I gathered online as a non-network engineer is that Yang and NetConf are becoming the industry standard for configuration. Many of the concepts map well to system configuration management and would even be very cool. I would really love it to have a system where I could have a candidate data store or the difference between the running and the startup config, so I can see what actually happened on that system. But right now, the software is not truly production ready, but I do encourage you to have a look at it if you feel very brave. So thank you very much. And if you have any questions, then please come to the front.
Thank you, Pieter, and apologies for the introduction. We were a bit out of sync on who would do what. So
that's okay. I hope I did well myself.
Absolutely.
Good.
Sander, you have a question.
Hello?
Oh,
there we are.
There he is.
So the things you mentioned about NetConf and Yang, especially NetConf, like two-phase commit, candidate configurations, all that kind of stuff. I wish that had actually been a mandatory part of the protocol, because I've seen too many network devices that don't have a candidate configuration, that don't have two-phase commit support. So while it's possible in the protocol, in the networking side. I mean, Melchior is standing there. I can fully confirm that Juniper does it the right way. But I've had other network devices where, it just wasn't as usable.
From what I gathered from the RFCs, there's I think the NDMA RFC, which defines which data stores must be defined. I believe many of the data stores and the transaction stuff is mandatory when you want to implement that, and I believe it's a part of the core right now.
Okay, that would be good, because I was just looking stuff up for a certain type of Cisco, and it was like, you can have a candidate data store. You just have to configure it manually first using the CLI.
Well, it's something.
Thanks, Sander. Roman, you had a question.
Yeah, thanks, Pieter. So I reminded myself that 2 years ago I saw a presentation of yours from Config Management Group, where you said that you created this NetConf wrapper for the Power DNS configuration. Mm-hmm. And I was quoting your presentation saying that it's great to use Yang outside of networking domain to configure stuff on the Unix systems. 2 years have passed. I never seen anyone doing that. Why do you think that is?
Why nobody's using Yang as a language to model their configuration?
Not Yang, Yang plus NetConf for doing anything outside of networking domain.
I don't know. It might be that network engineers and system engineers just don't talk that much to each other or live in such different realms. On the other hand, it might just be that NetConf and Yang it's relatively esoteric, especially when the bash or whatever shell you have on your Unix system is so powerful with all the different tooling that most of the network devices, I mean, they have a bunch of powerful stuff, but it doesn't have the general purpose-ness of a Unix system. It might be that. I honestly don't know why people don't use it.
Thanks.
There are also a couple of questions via IRC came in.
Yeah. It's a two-part question from Jeroen, which is, how many devices support this? And by this he means NetConf and Yang. And the second part of his question is, what about all devices?
The first part, I don't know. I would think a lot, based on the marketing materials I've seen on the vendors' websites. I mean, there are people who know this probably in the room. And sorry, what was the second question?
What about old devices?
I'm pretty sure they don't have this.
Okay, thanks.
Okay.